Write name and seat number again. We started the chapter amines. So I will, within 5 minutes, I will take a quick revision. This chapter is included in organic chemistry. It is having the weightage 3 marks, and with options, it is having 4 marks weightage. In old syllabus, the name of the chapter was compound containing nitrogen. At that time, there are two functional groups are there, amines and nitro. But in the new syllabus, remember only amines are kept for you. That's why the syllabus is only 3 marks. So what is mean by amines? This part is already completed, but I want to do the revision again. So amines are the derivatives of ammonia actually. In ammonia, there are nitrogen and 3 hydrogens atoms are attached. So the primary amine means when the one hydrogen of the ammonia is replaced with R group or AR group, it is called as primary amine. When two hydrogens of ammonia, these are replaced with two alkyl groups or two aryl groups, it is called as secondary amine. If all the 3 hydrogens of ammonia is replaced by 3 R groups or 3 AR groups, it is called as tertiary amine. So depending upon this, primary amines, secondary amines, and tertiary amines, these are classified. Then again, the secondary amines and tertiary amines are further classified as simple or symmetrical, then mixed or unsymmetrical, depending upon the type of alkyl groups attached to the ammonia, nitrogen. So the amines can be divided into two major classes like aliphatic and aromatic amines, depending upon the groups attached. If R groups are attached, the amines are called as alkyl amines, aliphatic amines. And if AR group is attached, the amines are called as aromatic amines. So these are the primary amines. Only one hydrogen is replaced with R group, where 2 hydrogens are replaced with R group. And all the 3 hydrogens are replaced of all the 3 hydrogens of ammonia, it is replaced with 3R group. So it is a primary amine, it contains NH2, secondary amine is NH, and tertiary amine only contains N. So we are discussing about the common names and IUPAC names. Again, I am coming to this table, yes. With the help of this table, you can understand the common names and IUPAC names. In case of common names, the word alkyl we have to attach first. It is in prefix, we have to attach the word alkyl group, we have to attach, and the amine is suffix. See, each and every this amines contains amine group at the suffix. So I think these 4 examples already I have explained. Then I am coming to this example. See, this is a CH26 and NH2. The common name is hexamethylene diamine. This hexamethylene diamine already we used in the chapter number 15, preparation of nylon 6,6. That is adipic acid is used. Adipic acid and hexamethylene diamine is used for the preparation of nylon 6,6. So why it is a hexa? Because 6 methylene groups are there, 6 CH2. So that's why it is called as hexamethylene. And diamine because there are 2 NH2 groups. When NH2 group is attached here and another NH2 group. is attached to. One is at right hand side and one is at left hand. Terminals. At the terminals, two NH2 groups are attached. So the IUPAC name is hexane 1,6-diamine. This 1 and 6 indicates the position of ammonia on the carbon number 1. One NH2 group is attached, and on the carbon number 6, another NH2 group is attached. Now, see, this is a aromatic amine. The common name is different actually. It is para-toluidine. So this is a para. P indicates para. Para-toluidine means at the para position. See, if it is considered as NH2 is considered as number 1. This is number 2, number 3, and number 4. On the number 4, there is a toluene group is there. So it is a para-toluidine. It is called as para-toluidine. And the IUPAC name C 4-methyl-aniline, because on the carbon number 4 methyl group is there. So why that's why it is called as 1, 2, 3, 4, 4-methyl-aniline, because this is aniline structure, NH2 and benzene. You know, in this example we already know this is a parent aromatic compound. Then NH2 group is attached to CA. This is not benzene. This is a cyclohexane ring. So the common name is cyclohexylamine. As per the rules of common names, amine is there, and cyclohexyl alkyl. This is alkyl group, and IUPAC name C. It is cyclohexanamine, because in IUPAC names of amines, alkanamine this group is introduced. E is replaced with E of alkane is replaced with ANAMINE, like this. So ethanamine, methanamine, propanamine, it ends with ANAMINE, like this. Alkanamine. See, this is one more example. See the difference between benzylamine and benzenamine. See, if one CH2 is introduced in between NH2 and benzene, see here, this is aniline, NH2 is directly attached to benzene, that's why it is aniline. But if the CH2 is introduced in between benzene and NH2, the common name is benzylamine, not benzenamine. See, don't make confuse between this benzylamine and phenylamine. If the phenylamine means aniline and benzyl, see, BENZYL. Benzylamine means CH2 group is introduced in between this, and the IUPAC name is phenyl, because this is a phenyl group. Then methanamine. This is phenyl methanamine. So this is phenyl, and this is a methanamine. Then next one is para bromo aniline, because at number 4 position bromine is there. This is number 1, this is number 2, number 3, 4. 1, 4 position, you know the para position, para bromo aniline is there. So the next one is IUPAC name is 4-bromo aniline, or it is also called as 4-bromo benzenamine. It is 4-bromo benzenamine, because at number 4 position bromine is there, and this is a aniline also, or you can give the name aniline also. 4-bromo aniline, it is also IUPAC accepted by the IUPAC, or you can write 4-bromo benzenamine. So these are the IUPAC names of some primary alkyl halides and primary allyl halides. Directly we are coming to the secondary amines. See, in case of secondary amines, the change is 2 alkyl groups are attached, or 2 aryl groups are attached here. So the nomenclature system of also different in case of these amines. See, the common name is a dimethylamine, because there are 2 methyl groups are there. So the names are dimethyl, because there are 2 methyl groups are there, and it is amine, it is suffix. So in case of IUPAC name, you have to introduce this N. This N indicates to this nitrogen, means this N indicates this to this nitrogen, which groups are attached. N methyl indicates to this nitrogen methyl group is attached here. N methyl methanamine. Larger amine, we have to take the parent N methyl methanamine, because this is a symmetrical There is no question of larger and smaller. But see this example, second example, one is the CH3 group is attached and another group is C2H5 group. One is methyl and one is ethyl group. So in this case, this is a parent because this is larger because it contains 2 carbon atoms here. So see the name, it is a N-methyl because to this nitrogen, this methyl group is attached. So N-methyl ethanamine. Why it is ethanamine? Because it is larger one. It is larger one. This is ethanamine is larger one. See, this is C2H5 is a larger alkane, which is a larger alkane. We have to take as a parent. Then see this example. This is secondary amine. One group is phenyl and another group is methyl group. So the name is C. N-methyl aniline. N-methyl aniline, or it is also called as N-methyl benzenamine. In this example, there are 2 benzene rings are attached here. See, this is one benzene ring. This is another benzene ring. C6H5. This is another. So the common name is diphenylamine, and the IUPAC name is N-phenyl benzenamine. N indicates the nitrogen to which this phenyl group is attached. N-phenyl, this is N and this is phenyl and this is benzenamine, or it is also called as N-phenyl aniline also. So I am coming to the tertiary amines, the nomenclature of tertiary amines. First I will discuss the common names. As there are 3 methyl groups are attached, so the common name is very easy, trimethylamine, because 3 methyl groups here, number 1, 2, 3 methyl groups are attached to this nitrogen. It is called as trimethylamine. Now come to the IUPAC name, 2 times N it is attached, because see here, these 2 groups are attached, N, dimethyl. Why it is dimethyl? Because the 2 methyl groups are there, and this is considered as a parent, which is a larger. But in this example, there is no question of larger because all the 3 alkyl groups are same. So the name is N dimethyl methanamine. But in this example, say one C2H5 group is there, and these 2 methyl groups are there. So name will be NN dimethyl, because 2 methyl groups are there. NN dimethyl ethanamine. Why it is ethanamine? Because it is a larger one. This alkane is considered as a parent because it is a larger one. Then next one, next example, see this example. In this 3 different groups are there. 3 different groups are there. One is methyl, one is ethyl, and another one is propyl. So first we will discuss the common names. Ethyl. Why ethyl is taken first? Because alphabetically order ethyl comes first. Ethyl, methyl, and then N-propylamine. Why this N indicates? N indicates it is straight chain propyl is there. So ethyl, methyl, N-propylamine. This is a common name, but the IUPAC name is very interesting. N-ethyl. Again, ethyl comes first as the alphabetical order. N-ethyl, N-methyl, N-methyl, then propane 1-amine. See the IUPAC name. N-ethyl means this ethyl group C2H5. Then N-methyl means this CH3, and propane 1-amine. Propane 1-amine indicates to the carbon number 1 this ammonia group is attached. So this is considered as the largest chain, CH2, CH3, and to the carbon number 1 the ammonia is attached. So make a practice of this at your home. Write the straight chain and then write CH3, CH5. Then you will understand how the IUPAC names will be. This is also quite interesting. See this example. This is one is a C2H5 group, one is a methyl group, one is ethyl group, and see this entire group is propyl CH3 CH3. So these three different groups are attached here. The common name is very easy: ethyl, methyl. So one is ethyl, one is methyl, and one is isopropyl. So the three different groups are there. One is ethyl, methyl, and isopropyl. So common name is very easy, but the IUPAC name is quite interesting. N-ethyl. N-ethyl, because alphabetically E comes first. That's why it is N-ethyl. Then N-methyl. This is N-methyl. And this is propane to amine. Now, why it is propane to amine? Because this chain is considered as a longest chain. On the second carbon, see, on the second carbon, there is a ammonia is attached, nitrogen attached. That's why it is called as propane to amine. See, these two examples are quite interesting. Such type of examples are asked for board exam. For 1 mark, write the name of the amine. And last one I will discuss, and I will move to the reactions. This is N dimethyl aniline, because it is simple. Two groups are attached here. Both the groups are same. That's why the name is di is introduced here. Dimethyl. These are the two dimethyl, and this is aniline. Now come to the IUPAC nomenclature system. N dimethyl benzanamine, or it is also called as N dimethyl aniline. So these are the common names and IUPAC names of primary amines. These are the common names and IUPAC names of the secondary amines, and these are the common. So make a practice at your home, then you can understand how the nomenclature system is introduced, and how the common names are given, and how the IUPAC names are given. Then preparation of amines. Now how the amines are prepared. First one is by ammonialysis reaction. Ammonialysis means it is a addition of ammonia. Excess of ammonia is added in alkyl halides, and we get the amines. We will discuss first how this reaction takes place. Ammonialysis means what? Ammonialysis is nothing but the process in which this CX bond is broken. The bond between this R and X, that is called as the CX bond, is broken by the ammonia. Such reaction is called as ammonialysis. It can be as per 1 mark. Define ammonialysis. So ammonialysis is nothing but the breaking of this RX bond, or the breaking of this CX bond by using excess of ammonia, is called ammonialysis. So in this ammonialysis reactions, we have to use the excess of ammonia. It acts as a nucleophile. And first we will get this substituted ammonium salt. So these arrows are shown, this lone pair of ammonia attacks here, and this will be broken. So first we will get the substituted ammonium salt, RNH3 plus X, plus sign is there because this lone pair is already given. So this is the salt, and we can get the amine from this salt. See, below here is given. When this salt is treated with NaOH, we get the primary amine plus H2 and NaX. This reaction is possible when excess of ammonia is used. If the percentage of this alkyl halide is more than the ammonia, then what will happen? If this alkyl halide is used in excess, then reaction will take place like this one. See, RNH2 means this primary amine first reacts with, this ammonia reacts with alkyl halide to get the primary amine. Then as this alkyl halide is used in excess, it again reacts to give the secondary amine, and the alkyl halide again reacts to give the tertiary amine, and alkyl halide again reacts with the tertiary amine to give final product is quaternary ammonium salt is formed. This possibility is there when this alkyl halide is used in excess. Remember, when this ammonia is used in excess, we will get only one product here, primary amine only. But when this RX is used in excess, it is called as it gives the 4 products: primary, secondary, tertiary, and quaternary salt. So this reaction is ammonialysis of alkyl halides. Clear cut, it is mentioned here. If ammonia is not used in large excess, means if the alkyl halide is used in large excess, then we will get the mixture of primary amine then secondary amine, and then tertiary amine, then finally you will get the quaternary ammonium salt. All these this ammonolysis reaction is carried out at the temperature 373 in a sealed tube. So it may be as for 1 mark or 2 mark. Then next one is see the order of reactivity of alkyl halides. Ri, alkyl iodides, they react very fast, then alkyl bromides, and then alkyl chlorides. Yes, this is not for your exam. This this is I have given for the students which are appearing for the CET, which are appearing for the NEET exam, which are going for the JEE exam. For these students I have given, but this will be not as for knowledge purpose. I have given this reaction. You can read at your home. Then the second reaction is reduction of nitro compounds. Now you are familiar with the word reduction. We are know the nitro means NO2 group is there. See, aliphatic and aromatic nitro compounds. Now you also know the aliphatic means what, then aromatic means what is meant by nitro compounds. So I'm not going to explain in detail what is this aliphatic aromatic. Nitro compounds means NO2 group is there, aliphatic means alkyl groups are there, and aromatic means ER, benzene ring is there. So these are reduced to primary amines, means RNO2 is converted into RNH2. This is called the reduction. And then the reduction reaction can be done by using, these are the reducing agent. First one is metal and acid mixture. SnSCl, this is the tin and HCl, or Fe or HCl, or zinc or HCl. This is a mixture with metal and acid. So all these are metals with acid, or it is reduced by catalytic hydrogenation. You know what is the catalytic hydrogenation? Platinum, palladium, ranitidine we are using as a catalyst, or you can use, this is very famous, lithium aluminum hydride. Lithium aluminum hydride is quite costly. Instead of this lithium aluminum hydride, you can use sodium borohydride, NaBH4. In the chapter alcohols, we already discuss about this lithium aluminum hydride. So this is a reaction RNO2 reduction. 6 hydrogens are used. SnSCl, we get RNH2 plus H2. This is aromatic amines are given. This is nitrobenzene. It is converted into aniline. So how the question will be asked for board exam? How will you prepare aniline by using nitrobenzene for 1 mark? For 1 mark, the examiner can ask such a question: how will you prepare this aniline by using nitrobenzene? Remember, so directly by reduction we can prepare this one. And how will you prepare this nitrobenzene from aniline? What we have to do here? Reverse one. We have to do the oxidation. NO2 to NH2 reduction, and NH2 to NO2 we have to do the oxidation. We can do the oxidation by using the oxidizing agents like caminophore, then you know copper is there, then CrO3. These are the oxidizing agents. So we can convert this NO2 to NH2 group, NH2 to NO2 group. Remember this one, this is as for exam. Then next one is reduction of alkyl cyanides or nitriles. You know the cyanides and nitriles, these reactions already completed in chapter number 10. Halogen derivatives, first time these cyanides are prepared by using alkyl halides, AgCN and KCN. When KCN is used, we get the cyanides, and when AgCN is used, we get isocyanides. These reactions already we discussed in the chapter number 10. But in this chapter, we have to do the reduction of these cyanides. So how these cyanides are prepared by using alkyl halides, here I have shown below. See, the question is there. Write the reaction to convert the methyl iodide. Methyl iodide is alkyl halide into ethylamine. Also comment on the number of carbon atoms in the starting compound and the product. So and this is we have to take first methyl iodide is taken plus KCN. When KCN is used, we get the cyanides, and when AgCN are used, we get the isocyanides. So here we get the this iodine is this CN is a nucleophile, acts as a nucleophile. it will substituted here and we get the Ki. So CH3CN, it is this reaction is completed in the chapter number 10, how this is prepared. So if this CH3CN is prepared, this is a Na(C2H5), this is Na and alcohol. This is a Mendes reaction. First, I will explain this Mendes reaction, and again I am coming back to this one. So what is this Mendes reaction, or it is also called as Mendes reduction? Mendes is the name of the scientist who discovered this reaction, specific reactions in which the cyanides or nitriles are reduced to the primary amines. So for the reduction reaction, we are using this is a solvent, sodium in presence of alcohol, and lithium aluminum hydride, it is used as a reducing agent, or you can use the H2Ni, we can use the platinum, we can use the palladium also, you can use any BH4. We can use any reducing agent here. But this is a Na and C2H5, this is a sodium metal, and in presence of alcohol, this is used as a solvent. So in this reaction, this is called a step-up reaction. Why this is called a step-up reaction? Because the length of carbon chain is increased, and step-down reaction means the length of carbon is decreased. I will explain how the length of carbon is increased here. So this is a general reaction. First, RCN, any alkyl halide, any alkyl cyanide, when it is reduced, we get here RCH2NH2. See the chain is increased here, CH2NH2. This is acetonitrile. It is also called as ethyl cyanide. It is also called as ethane. Three different names are there. Acetonitrile is there. It is also called as methyl cyanide. It is also called as ethane nitrile. Ethane nitrile because the two carbons are there. That's why it is called as ethane nitrile. On reduction gives ethylamine. Ethylamine. So two hydrogens are added here, another two hydrogens are added here, and we get the amine. Why this is called as step-up reaction? Because see, now again I am coming back to this one. See, in the alkyl halide, only one carbon is used here. In the alkyl halide, only one carbon is used, and see the product here, one carbon is extended here, one carbon is added. That's why this reaction is called as step-up reaction, because the length of this carbon chain is increased. That's why it is called as step-up reaction. In the first step, we get the cyanide, and in the second step, by reduction, this carbon is introduced. As we are adding this cyanide, one carbon is introduced, so the chain of the carbon is increased, and this is called as step-up reaction. Now, one question is asked here. Also comment on the number of carbon atoms in the starting compound and the product. In the starting compound, there is only one carbon, and in the product there are two carbons. So this is a step-up reaction. Remember, Mendes reaction reduction. Examiner can ask the short note on it. Write a note on Mendes reduction. So make a practice at your home. Take any example here. You can use the instead of this methyl cyanide, you can use ethyl cyanide also. You can use here aniline also. You can take aromatic and aliphatic nitriles also. We get the here extended. The chain will be extended, and we get the amines from nitriles. Then this is a reduction of amides. Amines and amides are different functional groups. In case of amines, there are RNH2, it is primary amine, then N, when the two alkyl groups are there, it is secondary amine. When the three alkyl groups are there, it is tertiary amine. But amide is different. Say amide means the CO group, carbonyl group is introduced in between this R and NH2. So this is called as amides. So primary amines having the same number of carbon atoms can be obtained. See, this is very important. Primary amines are obtained with same number of carbon atoms which are included amines. This in case of this amide, see this amide carefully. See this amide carefully. we don't know which alkyl group is used. If the methyl group is there, means the carbons are 2. So the end product is also contains the 2 carbons here. Means this is a preparation of a primary amines by using amides, which is having the same number of carbon atoms. Same number of carbon atoms. This CO is only reduced. This carbonyl. This CO is only reduced. This is converted into CH2. We know how this CO is converted into CH2 group. Many reducing agents we can use here. We can use here Wolff-Kishner reduction. We can use here Clemenson's reduction. We can use here lithium aluminum hydride and H2O. This reaction is already we discussed in the chapter aldehydes, ketones and carboxylic acid. How this CO group is converted into CH2 group. So in this reaction also this CO is converted into CH2 by using lithium aluminum hydride. If you understand the general reaction, we can solve thousands of questions. But the general reaction is very important, how this CO is converted. This CO is converted into CH2 because this specific reagent, lithium aluminum hydride, in the first step it reacts, and in the second step by acidic hydrolysis, we get here CH2. If this is not available, we can use the Clemenson's reduction, zinc amalgam HCl, we can use the Wolff-Kishner and Clemenson, the hydrazine is used. So I'm not explaining in detail. So you must know how this CO is converted into CH2, and the main important purpose of this reaction, whatever the carbons are used in the reactants, the same number of carbons atoms are present in the products. Then next one is Gabriel thalamide synthesis. This is again the name of the scientist, Gabriel thalamide. Gabriel is the name of the scientist. He used thalamide for preparation of primary amines. This reaction is a very big reaction. It is asked for 3 marks. If the Gabriel thalamide synthesis is asked for exam, it will be asked for 3 marks because it contains 3 different steps. This method is used for the synthesis of primary amines. In this reaction, following 3 steps are included. First step is formation of potassium salt of thalamide. So I will explain the side by side. This is a thalamide C. This is a thalamide. It is amide. Why it is amide? Because NH group is there. NHCO, and this is also CO. This is thalamide. So what is happening in the first step C? Formation of potassium salt of thalamide from thalamide on reaction with KOH. See, this KOH reacts with thalamide first, and we get here potassium salt of thalamide. See, this is the salt. This is a N minus and this is a K plus. This is a potassium salt of thalamide. So this is a step number 1. In the step number 2, see what is happening. This is a potassium salt of thalamide reacts with alkyl halide. We get here N alkyl thalamide. So in the second step, what is happening? This alkyl halide is added in this potassium salt of thalamide, and we get here N alkyl thalamide. Why, you know what is this N, what is this alkyl group, N alkyl thalamide. Then in the final step, what is happening? This again N alkyl thalamide, alkaline hydrolysis reacts with NaOH is a base. We can use here KOH, and we get this is the main product. Primary amine is the main product, and this is the byproduct. Remember, student consider this is a main product and this is a byproduct, so don't confuse it. This Gabriel thalamide synthesis is a preparation of primary amine. So this RNH2 primary amine is the main product, and this sodium phthalate is the byproduct. So these are the 3 steps. In the first step, we get the potassium salt. In the second step, we get the N-alkyl thalamide, and in the third step, we are getting amine, and this sodium phthalate is a one main drawback of this reaction is, it is written below, aromatic amines cannot be prepared by this method. See, we cannot prepare the aromatic amines by this method because in the first step, see, potassium salt of thalamide is used, and here alkyl halide is used. If the aryl halide is used here, because these aryl halides do not undergo nucleophilic substitution with the anion formed by the thalamide. Here, instead of this RX, if ARX is used, They do not react with this one because they are, nucleophilic aryl halides do not easily undergo nucleophilic substitution reaction. They easily undergo electrophilic substitution reactions. So this step is not possible. This second step is not possible. That's why we cannot get here ARNH2. This reason may be asked for board exam. Why? From Gabriel phthalimide synthesis, we cannot prepare aromatic amines. So you must know this reason because this is a potassium salt of phthalimide. Aryl halides do not undergoes nucleophilic substitution reaction with the potassium salt. So may I make a practice at your home? Draw the structure of this phthalimide two, three times. Make a practice of this reaction. If this is asked for exam, it will be asked for 3 marks. Remember, means it entire topic of this chapter will be for the one reaction. So very carefully we have to do the study of organic chemistry. If you skip the reaction and if it is asked for exam, you will lose your marks. Then this is very, very, very important. Very, very, very important because 10 to 15 times it is asked for board exam. Hoffmann bromoamide degradation. This is similar to this one, reduction of amides. In these amides, we get the same number of carbons here, but in these amides, we get less number of ammonia. It is formed with 1 carbon less. This is degradation reaction. First, I will explain what is this Hoffmann bromoamide degradation. Hoffmann, this is the name of the scientist who discovered this reaction. This is the degradation reaction, remember. It is also called as Hoffmann rearrangement also. Degradation means we are going to remove this CO. Means we are removing this CO and we get the amine which is degraded. Hoffmann developed a method for conversion of amide into primary amine containing 1 carbon less. This is a very important word, 1 carbon less. We are getting the amines with 1 carbon less. And in this previous reaction, we are getting the amines with equal number of carbons. What are the carbons used in the reactants? We get the same number of carbons here. But in this reaction, Hoffmann bromoamide degradation, we are getting the amine with degraded. See here RNH2 only. This RNH2. See, this is an example I have given here. General reaction. This is amide. And why it is called as a bromoamide degradation? Because this reaction is brought about by warming an amide with bromine. Bromine is important here. Bromine and aqueous alcoholic solution of KOH or NaOH. That's why it is called as bromoamide degradation. The overall result of the reaction is CO group from the amide. It is degraded and the product will contain 1 carbon less. So this reaction is asked for 2 marks or 3 marks. Very important reaction. Many times it is asked for board exam. So make a practice at least 10 times write this reaction. Write this reaction for 10 times. This is your today's homework. Write these reactions, then read the chapter amines carefully, go through the nomenclature system, what is meant by primary amines, what is meant by secondary amines, go through the ammonolysis reaction, what is Gabriel phthalimide synthesis. Daily we have to do the practice for organic chemistry. Side by side, write the preparation of nylon 6,6, nylon 6, what is the elastomer, what is vulcanization of rubber, what is Markovnikov's rule, what is anti-Markovnikov's rule, what is SN1 reaction, SN2 reaction, then how the alkyl halides are converted into cyanides, how the alcohols are converted into chlorines by SOCl2, then what is the reaction of HBr or Lucas reagent. So these questions are again and again asked for board exam. So I will stop here. I will just discuss this example and I will stop here because only 1 minute is remaining. See, this is acetamide treated with bromine and aqueous solution of KOH. We get here the CH3NH2. This CO is degraded. This CO is degraded. So I will